Chapter 12, Lesson 2 covers statistics and parameters. Diving into this one, we can say that the statistics of a sample are used to draw conclusions of an entire population. This is called a statistical inference. In the scenario above, which we don't show here, each student takes a random sample of pennies from the jar. The jar has 1,000 pennies in its population. From there, we can take and say that a statistic is going to be a measure that describes a characteristic of a sample. A parameter is the measure that describes a characteristic of the population, and the parameters are fixed values that can be determined by an entire population, but are typically estimated based on the statistics of a carefully chosen random sample. A statistic can usually and will, let's try that again. A statistic can and usually will vary from a sample population. The parameter, however, will not change, for it represents the entire population. Are you confused yet? I understand why. And it's going to get ugly because we are going to be getting mad in this lesson, I do believe, which means we're diving into mean absolute deviation. It is not fun. It is brutal, in fact. But today, you are going to learn how to use a graphing calculator to find the MAD instead of just doing it by hand. Something that my 7th graders last year did not get to do. So, moving forward, I'm going to find my button here. For this problem, it says, identify the sample and the population of each situation. Then describe the sample statistic and the population parameter. So at a local university, a random sample of 40 scholarship applicants is selected. The mean grade point average of the 40 applicants is then calculated. All right, so that's given to us. The sample is going to be the 40 scholarship applicants. Okay, that's going to be how many is going to be pulled out of it. From there, the population is all of the applicants. The sample statistic is going to be the mean grade point average of the sample. So the mean grade point average of these 40 scholarships that they pulled out here, that's going to be your sample statistic. And the population parameter, that's going to be the mean grade point average of all of the applicants combined. So if we took all of the applicants in there and found their grade point average, that would be the parameter of the entire population. Confused yet? Probably not. It's getting better, isn't it? Let's keep it going. Next, we're going to look at B, where we're going to have a stratified random sample of registered nurses is selected from all hospitals in a 3-county area, and the median salary is calculated. So for this one, our sample is going to be randomly selected registered nurses from the hospitals in the 3-county area. The population is going to be all of the nurses that are in the same area. And then we're going to have a sample statistic. That's going to be the median salary of the nurses that were sampled. And then from there, you've got the population parameter. That would be the median salary of all of the nurses in that 3-county area, not just the one selected. Is it starting to make a little more sense? I hope it is. Let's keep it going. As shown in lesson 012, which we didn't really cover, univariate data can be represented by measures of central tendency, such as mean, median, and mode. That should be very familiar to you. Univariate data can also be represented by measures of variation that assess variability of the data. Some examples are range, quartiles, interquartile range, mean absolute deviation, the MAD, and standard deviation. So now we're going to get into the ugly stuff, the mean absolute deviation. Guys, I hate doing mean absolute deviation. You're going to hate doing mean absolute deviation. It is the average of the absolute values of the differences between the mean value of each value in the data set. That sounds really confusing. The mean absolute deviation is used to predict errors and judge how well the mean or the average represents the data. If you recall, to find we're going to start off by finding the mean, and they're going to take and represent mean with an X with a line over it. Anytime you see X with a line over it, that means the mean or the average of the data set. Then you're going to find the absolute value of the difference between each data value, which they have referred to as X sub n. That just represents each individual data value, and the mean. And they indicate this when the absolute value bars, because sometimes it can be positive and sometimes be negative when you work it. You only want the positive final solution of the mean minus each individual data value. And after that, you're going to add up all of those things that you came up with doing this formula. You're going to have some decimals in there probably. And then you're going to divide it by the number of data values in the set. This is not fun, guys. It really isn't. So let's dive in. They give you the formula, which says that the difference of the mean in the first data value plus the difference of the mean in the second data value plus the mean in all the data values divided by the number of data values is going to give you your mean absolute deviation. I'm not going to ask you to write this formula down for your homework. You will have more than enough writing to do as it is, and that formula is just kind of pointless. Note that the ellipsis that you see right here is the formula. It can be in the formula means and so on. So we stopped at 2 and then we went on to n. So the next one would have been x sub 3, x sub 4, x sub 5, all the way until you run out of them, and that's going to be your last value, which would be x sub n. We good? I hope so. Now, let's look at example number 2. Each person who visited a comic book shop's website was asked to enter the number of comic books they buy each month. They received the following responses in one day: 2, 2, 3, 4, and then this wildcat out here buys 14 comic books in a month. It says find and interpret the mean absolute deviation. So the first thing they did is they found the mean. They added up how many comic books each one said they bought, divided by the number of people in the survey, which was 5, and they got a mean of 5. All right, that part's good. Now we have to find out how far each one of these data values are from the mean or average of 5. So for the first data value, we're going to take and boop, here we go. They took x sub 1 was equal to 2. Therefore, the difference between the mean and x sub 1, well, the mean was 5, x sub 1 was 2. We see that right there as a first term. That gave us 3. And then they're going to do the next data value, which is also a 2 right here. So x sub 2 is equal to 2. They did the mean minus x sub 2, which was 5 minus 2, also known as 3 again. Our third data value is 3. So we're going to take and find x sub 3 is equal to 3. The mean minus x sub 3, well, the mean was 5, x sub 3 was 3, and that gave me 2. And then here we have x sub 4, which we saw was 4. So the mean minus x sub 4, that gave you 5 minus 4, or a difference of 1. And then we have our wildcat out there. X sub 5 was equal to 14. We see that one right here. So the mean of 5 minus 14. Well, that gave us a negative 9. But remember, we're dealing with absolute values here. So we had a positive 9 for our difference there. We good so far? I hope so. Now we're going to add 3, 3, 2, 1, and 9 together. And when we do that, it's going to give us 18. And then we're going to take that 18. Remember, you have to divide it by the number of values. So you're going to plug in that 18. These 3, 3, 2, 1, and 9, and 18, those go on the top right here if you wanted to plug them in. And the 18 divided by the number of values gives you 3.6. So you have a mean absolute deviation of 3.6. So on average, the number of comic books that are bought by each individual are within 3.6 units of the mean, which was 5. That's not really close. It really isn't. The mean absolute deviation was 3.6, which indicates the data on average are 3.6 units away from the mean. This value is significantly influenced by the outlier, which is 14, and without the outlier, the data set would have been 2.75 with a mean absolute deviation of 0.75. That would have been a lot more consistent but that outlier 14 really screwed everything up. Now, in a set of data, the standard deviation shows how the data deviate from the mean. A low standard deviation indicates that data tends to be very close to the mean, while a high standard deviation, that indicates the data are going to be spread out over a larger range of values. The standard deviation is represented by the lowercase Greek letter sigma, which looks like an O with a funky curlicue coming out of it. And the variance is the same thing squared. It's going to be sigma squared. So the variance of data is the square of the standard deviation. Moving forward from there, standard deviation, you're going to start off by finding your mean. That's your x with a line over it. After you find the mean, you're going to square the difference of the mean between each one of those x sub n values. Okay, so we took where we had found find the sum of all the step values in step 2, and then divide by the number of values in the data set. I know this is looking confusing. Hang with me. We're going to get through it. This value is going to be the variance. So first we learned how to find the mean absolute deviation. Now we're trying to find the standard deviation, which is just another way of looking at it. Next, we're going to take the square root of the variance. And when you look at it, what you have here is the formula of the MAD, except each one of these things are squared. Okay, see those are all squared? In MAD, they weren't squared. So the same formula as the MAD with each one of these items squared. You add them up, you divide by the number of data values, and then you take the square root of it, and that is going to give you your standard deviation. That's a lot to take in. Study tip: the mean of the sample and the mean of the population are calculated the same way. The x with a line over it refers to the mean of the sample. Meanwhile, this funky looking U here refers to the mean of the population. However, in this text, we are only going to be using the x with a line over it. We're going to let it refer to both the mean of the sample and the mean of the population. Now, this video is getting a little long-winded, so before we dive into example 3, I'm going to wrap this one up, and then we'll come back with a whole new video to do the next part of the lesson.